Okay, Proterozoic. So on our clock of errors, the Proterozoic is yellow. Let's look up close here so you can see this. You'll end up making a graph at the bottom to go along with your clock. Let's read it together. So our Hadean is, so you could even, we talked about it's 375 million years every hour. So I think I'll stop you there. It's about 2 hours. So without looking, how long was the Hadean? You better get out some paper real quick. It's going to be 375 million plus 375 million. We'll check the chart later. So your next math question is 2 to 3, 3 to 4, 4 to 5. It's going to be about times 3 is the length of the Archean. Check your answers after. Okay, now the Proterozoic, here we go. 1, 2, 3, 4 with a little bit on each side. So it's about 5 hours of our clock. It's the largest amount of time so far and always on the clock of errors. So what's happening in the Proterozoic? Obviously a lot. Here we go. So the Hadean time was the time of volcanoes forming the Earth's crust, and there was no life at all on the planet, so it's black. The Archean is when the volcanoes exploded and formed huge clouds over the Earth. The clouds dumped so much water on the Earth that the first oceans were formed. This was the times of the bubbles and the thinkers, and the first sort of cells were the ancestors of the life forms that would evolve on the planet. As time marches on, a new era begins. This was the Proterozoic era. The long period of bubble thinker experiments has created real cells with real memory. The Proterozoic era is yellow on the clock of errors to remind us of the work of the sun. The sun formed a partnership with cyanobacteria that had formed at the end of the Archean time. They worked together to put oxygen into the atmosphere around the Earth. But there was another problem. Cyanobacteria had used so much of the carbon dioxide from the atmosphere and put so much oxygen into the atmosphere that there was danger that the cyanobacteria would be unable to continue to live and do its work. But a miraculous thing happened. The oxygen-rich environment prepared the way for a new kind of life form, the eukaryotes. These organisms used the oxygen to live and grow, and they gave off carbon dioxide as waste. Now the cyanobacteria and the eukaryotes would work together as partners in the ancient seas. This partnership helped create the environment in which all the more complex life forms could now grow and develop. As the Proterozoic continues, another environmental crisis takes place in the ocean. My cat won't stop knocking on the door. You're interrupting my lesson. All this time, rain continues to fall on the Earth. The Earth is getting colder. In the seas, there is a buildup of minerals. It is hard for the baby cells that came from the bubbles and the thinkers to survive in that salty mineral water. They feel afraid and angry at the salts for polluting their watery home. The salts explain that they were pushed down into the seas by droplets of water that fell out of the mountains, that fell on the mountains, and hurried down the sides to the seas. So the frightened cells cry out at the water droplets to stop bringing the salt into their watery home. The water droplets explain that the water always seeks the lowest level. Because they had been dropped on top of the mountains, they had to flow to the seas. So the little cells look angrily at the wind and demand to know why it had carried the water to the tops of the mountains. The wind explains that it's doing its job too. It must move the heat from the belly of the earth to the colder feet at the mountaintops. During its work, the water vapor climbs on its back. This works well until they reach the cold mountaintops. By then, the water vapor turns to liquid and becomes too heavy to carry. The water must fall back to the earth, the wind explains. The tiny life cells look around for something else to help them solve their problem. Even the sun is not able to help the cells get rid of the salts. But remember, the cells came about after thousands of years of bubble thinker experiments. They are inventors at heart. A new type of cell appears that can eat the poisonous salts. The tiny new animal uses the salts to build protective shells around their bodies. These animals were called foraminiferans. There are so many of these foraminiferans that more than a third of the ocean bottom is made up of their remains. Rocks on the ocean floor contain fossils of their shells, letting us know about their important work. The foraminiferans saved the cells from a salty death and kept the salts from threatening the cells again. Let's make the Proterozoic. Here we go, I think. Can you see okay? So we are going for our yellow paper now. Hope you can see this okay. This is another very wide cut. I think I'm going to have to make my paper a little bit wider. So I'm going to match up on this side first and use the hole in my protractor right here. Line up my 0. There's my 0. Oops, can you see? There's my 0 here, so I need to pull. I'm going the wrong direction. Okay, here's my 0 here. And gosh, look at my, is this still my yellow? My yellow stops around. It's pretty hard to see. It's gonna, wow, you guys are gonna be surprised at this. I just marked, that's even too far. It's right about here as I'm peeking through. Geesh, you guys ready for this? I hope you can see this. It's pretty exciting. All the way to about here. So, starting at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. It's about 160 degrees is what I'm seeing. So I am going to now just use this as a ruler. I'm pretty much just using this to make a straight line from my point out. And then I will make my cut and see if I came close. I hope so. It's hard to make a perfect 360-degree circle. You will find that. So, how'd we do? If this is, I didn't do so well in this one. Oh, that's because I was holding it wrong. Okay, how are we doing now? Starting here. Coming around. It's a little bit wide. I think I'm going to cut a little bit off here. I might just make it a few degrees smaller. I hope you can see this. Okay, let's see now. Yep, that looks good. And so my circle outline is about here. I'm not going to cut that part yet. I think we've been filming long enough. But how many degrees was this after all? All the way to 150. It's 155 degrees is what I'm getting. Okay. We will be back to do the Paleozoic